Alright class, next I'm going to do the which measures do we use exercise in your notes. And on this one, let's go ahead and take this data, 2, 3, 4, 6, 7, 8, 2, 3, 4, 6, 7, 8, and put it in our one quantitative variable on Staplet. And the variable name will just be data. We didn't have any special name for this. Begin analysis. And see how I made a little column for range and IQR? You want to write those down too. It's good to know those as well. Mean is 5. Median is 5. Range would be 8 minus 2 is 6. It's biggest minus smallest, 6. And IQR is going to be Q3 minus Q1. So it's 7 minus 3, which is 4. All right. So the next one they want us to do is 2, 3, 4, 6, 8, 20. What happens when you add a big number to this group? Like it's called an outlier. It's bigger than all the other numbers, right? So let's do that. 2, 3, 4, 6, 8, 20. And begin analysis. And see, we got this outlier way out here skewing this graph to the right. So this is a skewed right graph. And what happened is this outlier caused the average to go way up, the mean, 7.167. 7.167. See, it caused the mean to go way up, but the median was not affected by this outlier because the median is just looking at the middle one, right? Now, what did range do? Range is 20 minus 2, that is 18. And what did IQR do? Q3 minus Q1, 8 minus 3 is just 5. So see, the IQR was not affected by that outlier much either, and the median was not affected much by it. Now what would happen if I made this last one 50 now instead? So the outlier got even bigger and skewed it even more. 2, 4, 6, 8, 50. And begin analysis. And look at our graph, we got it way out here now, this number all by itself. That's an outlier for sure. And it's skewing the data to the right. Because we got like a long tail that we got to make for the data all the way to 50. And look at the mean now, 12.167. And the median is still not affected, it's still 5 because the middle number, like if you chop in the middle right here between 4 and 6, that'd be 5, right? Now the range is 50 minus 2 is 48. And the IQR is Q3 minus Q1, 8 minus 3 is 5. See, the IQR is not getting affected much either. So the mean is pulled in the direction of the skew or outlier. But for this instance, we meant skew. So median and IQR, see how they stayed about the same? They are resistant to the skew. So if your graph is symmetrical, you know, all the data is nice and neat in one area and kind of symmetrical, and you don't have any crazy outliers like that, and there's no skew to the data, you would use the mean, and you could use range. But if it's skewed, you want to use median and IQR, because the median and IQR are resistant to that skewing, and it still gives you a more accurate interpretation of the data. Like where the true middle is. The middle really is towards 5, right? No matter how big this number is on the end, the middle's at 5, right? Right between 4 and 6. So it gives you a better interpretation of the middle, of the center. So if the median is equal to the mean, see if they're about the same, like up here, that is symmetrical. If the mean is bigger than the median, where you see how it started getting bigger, that means you are skewed right. That means there's some sort of outlier to the right, or there's more outliers to the right that's skewing that data to the right. And that it would cause the mean to get bigger. Now, what if we went the other direction, and I'm going to show you a skewed left, like say most of the data was, 44, 46, 48, 50, 52, and 54, right? Let's do those in begin analysis. Like the data's out here in the 40s and 50s. See how mean and median are about the same, 49, 49? But if I skew it to the left by putting a really small number in here, 0, which would skew the graph to the left. See how it skewed it over to the left like that? We skewed it over to the left. Now, look at the mean versus the median. See how the median is bigger now? So, this happens when you are skewed left. And your data is skewed to the left, that's going to cause the median to be bigger. Because think about it, when you push a number over to the left like that, it's going to drag the average down. It's going to cause the median to be bigger. That 0 is dragging the average. Someone made a 0 on a test, it would drag the whole class average down a lot. But if somehow somebody got extra credit and made 1,000 on a test, it would drag the mean to the right, and it would skew the data to the right. So skewed right means the mean's going to be higher, the average will be higher, and the median will stay about the same. Skewed left means the average will get way lower, like that 0 on the test, but the median will be about the same. And you want to use the median in those situations because the mean is not accurate. All right, that is it for this example.